Hello students, let's learn a new topic of differentiation under integral sign. In short, it is called as DUIS. I'll explain first of all the working procedure and then we'll see some examples. Consider an integral f of x dx. What do you mean by this? It clearly means integrate f of x with respect to x, and the answer, if you can evaluate this integral, the answer would be containing which will be function of x and plus constant of integration c would be there. So it would be some function, maybe g of x. If I write an integral f of x dx within the limits a to b, so this will be free from x and there won't be any constant of integration c as such. But if I consider an integral between the limits a and b, it is f of x comma alpha dx. So what would be its answer? The answer would be certainly free from x, free from constant of integration, but would be containing alpha. So instead of denoting this integral by I alone, let's denote it by I alpha. So now, if you can solve this integral using any known method, get it solved. What do you mean by known method? Integration by parts, substitution, partial fraction, or any typical integral which you have seen before in 12th standard. I repeat, if you can solve this integral using any known method, get it solved. If you are unable to solve this integral using any previous methods, then only think of using DUIS. Now what is the rule of DUIS? Here we consider a simple case of DUIS rule where the integral limits are purely constants. Here the integral limits are not functions of parameter. This alpha is constant and this is called as parameter. Every constant is parameter, every parameter is constant. So here we discuss a problem with single parameter first of all, and then we'll have some examples with more parameter as well. So let's denote the integral by I alpha and let us use the method of DUIS. So here if I write now differentiate, this is with respect to parameter alpha using the powerful tool of DUIS. Now it will be di by d alpha, I being function of alpha, alpha is the only independent variable, differentiation will be complete. And here the rule of DUIS appears, it is integral within a to b, partial derivative of the integrand with respect to parameter alpha, and its integration is taken with respect to the independent variable x. So the new integral which you find possibly would be easier than earlier one. So now evaluate it using the method. So get it solved. So obviously the answer would be free from x, free from constant of integration c, but would be containing alpha. Now if I write di equals to this function of alpha into d alpha, so it becomes very simple differential equation of first order first degree in I and alpha, where variable I and alpha are already separated. So mere integration on each sides gives the solution. So the integration on left side would be I, appearing from di by d alpha must be I alpha, and the integration you carry out using your known method on right side, and there would be plus constant of integration c. Now to know value of c, we'll have to impose a condition on alpha. So here in this case, you choose your alpha in such a way so that your I alpha becomes simple. Now what is the meaning of I alpha is becoming simple? You make a choice of alpha so that if you can make integrand 0, it would be really good, or you make a choice of alpha in such a way so that you can solve that integral within few steps. So in short, choose alpha in such a way so that I alpha is solvable. So when you replace alpha, you get I alpha value. you have this value, you get C value. So it means you get value of C, and that value of C you resubstitute here and you get I alpha, which is going to be function of alpha plus the constant of integration C, and the I alpha, which was TDS, is made very simple using powerful tool of DUIS, and here lies the importance of DUIS. Now this was an example with one parameter. Let's have a case with more than one parameter. Say for example there are two parameters alpha and beta. Now there is no set rule. See, the thing is, when you get more than one parameter, you are free to choose any parameter to answer that question, and definitely you get the answer for sure. But before deciding that parameter, in order to make that integral simple, you can decide on some tricks. If there are two parameters, say alpha and beta, and if you observe, by interchanging their places, you get some constant times original integrand, it means the choice of parameter is unimportant. Say for example, if you interchange their places, alpha replaced by beta and beta replaced by alpha, you get original function is constant times new function. It means choice of parameter is unimportant. Say for example, there are more parameters alpha, beta and gamma. Same trick works once again. If you replace alpha by beta, beta by gamma, gamma by alpha, and by doing so, if you get constant times same integrand, it means choice of parameter is unimportant. But if you don't get constant times same, it means choice really matters. So in such cases, before you decide on parameter, you do some rough calculation and check with which choice of parameter the calculation would be more easy, and accordingly decide on parameter. It's also quite possible there are more than two parameters, say alpha, beta and gamma. But if you observe, by replacing alpha by beta and beta by alpha, you are getting same integral is constant times same. It means in such cases, it is advisable to choose parameter alpha or beta, but must not be gamma. Alright, let's see some such examples in next video. Thank you.